it's that shape. If I flip it that way, it's that shape. Until I start to give you your brain cues, you are only piecing together a bunch of two-dimensional images, right? Your brain uses things like shadows. It uses, what's it called, where things fade into the background? Perspective. Thank you. I pointed at your designer husband and you knew the answer. So we operate in the third dimension, looking at things two-dimensionally. So remember that 2D world I drew with little shapes? I had the kids cut out shapes and put them into their two-dimensional pieces of paper world. They cut out little pink hearts, and then I said, now write something on the heart, like something that you're excited about, something that you love, like, ice cream, feelings that you might be feeling, like sadness or happiness. In that two-dimensional world, there's a lot going on that person, but the other people in the world can't see that. They can only see what they can see. In a three-dimensional world, imagine taking a bunch of little hearts with something written on them and gluing them all together, and now you have this like three-dimensional heart. What would it be like to actually see in 3 dimensions? Let's try to imagine what it'd be like to see in 3 dimensions. When you're seeing in 2, what you're doing is your eye, the photons of light are reflecting off the thing and into your eyes, and you're getting data on basically a 2-dimensional space. If you were seeing in 3 dimensions, you would be able to get data on the entire thing. You would be able to look at this and perceive not just this side, but this side, underneath, and all around it. Weird, right?
Yeah.
If I could truly see in 3 dimensions and I could look around this building, I would be able to see the kitchen, even though the kitchen right now is opaque to me. I would be able to see inside of the walls. I could have X-ray vision because I would be getting perfect information on all of the dimensions that everything in the space is taking up. And it would feel like I'm Superman. It would feel like a superpower. Yeah, it would feel like a superpower. But it would really, and it's hard for us to perceive, because for that 2-dimensional person, that little heart person, it's hard for them to perceive 3 dimensions. And to try to convince them that there's 3 dimensions, they'd be like, you're crazy. Like, you're breaking my brain. And that's what it would be like for us to try to imagine seeing in 3 dimensions. Okay? Okay, so now, are there only 3 dimensions? All right, so we've got 1 dimension, 2 dimension, 3 dimension. What is another dimension that we know of? Time and space are really...
Are they the same?
Time and space are part of the same... Time and space can't exist without each other. We won't try to go into that, but time and... That's why they call it space-time. Space and time are 2 sides of the same coin. So when we start to look at an atom and we start to pull an atom apart and we start to look at what makes an atom happen, really crazy things happen inside of an atom. Things stop working like they work out here in the macro world, and they start going totally crazy. So the particles that make atoms work, depending on the particle you're looking at, can do really weird things. Like, for example, the particle can be in many places at once. The particle can be here and here at the same exact time, and it's the same particle.
When you break it up?
When you actually look inside of an atom and what makes all of our atoms actually work, take a hydrogen atom. You've got electrons, you've got protons, and you've got neutrons, and then inside of those things are subatomic particles that do all this wacky stuff. So now we're inside of like quarks, we're looking at stuff that is really hard for us to understand, but they behave really, really differently. For example, the things inside of the things inside of atoms.
Okay,
Yeah,
so
I'm a couple of.
Ready? Here we go. Atoms, protons, electrons, neutrons.
And then the stuff inside of those, yeah, quarks and other things, right? So now there's, kind of like these strange things start to happen. For example, scientists just recently took a subatomic particle in one location. It was like Germany or something like that. And then they made that same subatomic particle appear in a completely different location thousands of miles away. And they measured it, and those two particles, if they measure them at any given point in time, were exactly the same. So weird things like that. And by the way, you can do that across vast, vast distances. In fact, distance doesn't even matter. You can make particles appear in two different places in the cosmos just because of how quantum entanglement works and how these subatomic particles actually function. Okay, this is how Star Trek can beam you somewhere. Yeah, and remember,
I thought this is why you do like two people in the same, you double numbers.
remember, as we start talking about omnipotent and omnipresent and traveling through time and being independent of time, you can see we're starting to make room for the God of the universe here. So there's not just 4 dimensions, though. So mathematicians and quantum physicists have gone into the subatomic particles to try to figure out what makes this and why, and where does it come from, and can we measure it, and can we build experiments off of it. And when they look inside of the atom, they can build all these really crazy mathematical models that should pencil out to everything making sense. Hey, we know we can measure these subatomic particles. If we can measure them, they should do this. And if we put that into a model, then mathematically it should get this. It gives us things like the weight of these particles, or how they move through space, how time affects them, right? All these mathematical models that you can use just by measuring how these things operate. Now, when they build all these mathematical models, they go, okay, we've got a problem. It doesn't pencil out. 4 dimensions does not pencil out. And so then they started going, okay, let's reverse engineer it. Let's figure out what pencils out and then kind of back into the variables that are missing and blah, blah, blah. And so what they've figured out so far is a whole bunch of other dimensions wrapped up in our universe, wrapped up even inside of an atom, inside of these particles. So you've got 11 dimensions that they've at least been able to mathematically pencil out. They don't understand them. They don't know what's possibly in them.
Do they have names for them?
I don't know if they have names for each dimension. But they mathematically at least have figured out that something's there, and until they can prove or disprove that, it's kind of the model they're working off of. So then the question is the God of the universe, if he is not in these dimensions, if he's sitting out here, I'm going to draw like a star or something. This is him. God. What could we look like to the God that's sitting outside of these dimensions? If we can see a 2-dimensional person and go, dude, you don't understand. Like, I see all this about you, but you have to take my word for it because it's there. You just can't see it. What could a God of the universe see if he was looking at us in our little 3-dimensional world? One, he could probably look through walls, and it wouldn't be magical thinking. It would just be his nature. It would be how you perceive 3-dimensional beings. Could he see through time? Could he look at Greg and see him as a baby, him as an old man, and everything in between, and get perfect context for where he is right now in this moment, as if when we just observed that molecule? Could he see thoughts? Could he see feelings? These are just things happening in these dimensions here. That's not hard, theoretically, for a being that sits outside of these dimensions to look in. Now, I don't know where to take these. That's crazy time. We can't perceive these. So when you talk about a God that we can't understand, that's infinitely a mystery, there's a lot in there. And as we learn, as we grow as a species, we may start to learn more about these things. We may be able to manipulate things inside of these dimensions. But we're still discovering this thing that he created, that he looks in, and to us 2,000 years ago, it seems magical. To us now, it's like, man, that makes sense. He created this mathematical universe and can use it. So when we talk about using the prophetic, I don't think of using the prophetic like magical thinking, like rubbing a lamp or wishing really hard. I think of the God of the universe with a perspective on who I am that's X-ray vision, that is more than X-ray vision, it's more than I can even wrap my mind around. And if I ask him, what do you see about my situation, about myself, about the universe I'm in, that's a really, really good perspective to tap into. Okay, so that's just one part of how we can start to wrap our minds around this crazy universe that we live in. Dan, can you show that first video?
When people talk about the universe, they usually mean the vast expanse of space.
It's about 5 minutes.
Billions of light years across that they can see with radio telescopes and cosmic imaging.
They think about stars and galaxies and planets and all the big stuff out there.
You have astronomical bodies moving under the force of gravity.
There are laws of nature, and you think that the laws are right once and for all.
However, there is another universe, an unseen world that governs everything we see.
When we go down in size, trillions of times smaller to the microscopic world, the rules are much less intuitive than the ones we're used to from the large-scale world.
The magic of the microscopic universe begins at about a 10/1000th of a meter, or the size of an atom. Matter behaves so differently at this level that scientists have developed an entirely new set of rules to describe what's going on. They call it quantum theory, and what it says is extraordinary.
This baseball represents a subatomic particle, like an electron or a photon of light, that routinely does all sorts of weird, strange things in the microscopic universe. The subatomic version of this baseball can be invisible, can go through solid objects with ease, can be in multiple places at the same time, and can seemingly go backwards in time and change the past. This means I could throw this microscopic baseball to first base and to home plate at the same time, or change the seemingly predetermined outcome of a play while it's still going on. Now, this is the stuff of science fiction, but really, we know it to be true, or at least it appears to be true in our quantum world. We get all sorts of weird things happening.
If scientists can understand how these weird things work, they'll be able to put them to use in our everyday world, revolutionizing modern computing and perhaps even allowing us to communicate across the cosmos instantly. The key to making these miracles come true is a process called quantum entanglement, and scientists are already harnessing this astounding discovery for both civilian and military purposes.
In quantum physics, what happens to an object over here can instantly affect an object over here, and over here could be millions of miles away.
This is how it works. When two subatomic particles interact, they can become entangled. That means their spin, position, or other properties become linked through a process unknown to modern science.
If you then make a measurement of one of the particles, then that instantaneously determines what the behavior of the other particle should be. And when the experiment is done, it's found that indeed the other particle's quantum state is exactly determined once you've made a measurement of the partner particle's quantum state.
That means if a scientist observes one entangled particle and forces it to spin clockwise, the other entangled particle will immediately start spinning in the opposite direction. That seems intriguing, but it's hardly earth-shattering until you consider that the two entangled particles can be separated by billions of light years. And still, the moment you observe one particle's spin, you've dictated the other particle's spin.
That's weird, because it may suggest that information has traveled instantaneously, faster than the speed of light, from one particle to another. I don't understand it. I don't know that anyone does. Spooky action at a distance, as Einstein called it.
Weird, right? Okay, you can stop it there. You know, when you look at like what the Bible said about how the earth was created, you know, it was started with let there be light, and then it progressed through, you know, creating the oceans and separating from the land, and eventually you got to animals or fish, and then everything else. It's funny how the Bible predicted that, and it wasn't for another couple thousand years, well, more than that, that science came along and said, oh yeah, that is kind of how that happened. That is the order in which, even if you're not a young earth creation, if you're just a pure, like, you know, how old is the earth, and I can see fossil records, and you just purely look at the science of the earth, it did actually get created and progressed in the way that the Bible described it. Not in the literal 7 days, but in the same order. And so it's not unheard of for science to sort of catch up with religion. But here, as you know, I was looking at this video, and I was thinking of all these things about, you know, what the Bible says God is. And, you know, we talk about Jesus after he was risen, that he suddenly started to show up in different places in ways that kind of defied physics, right? This idea of teleportation. Speaking with God in our internal thoughts. We think it's weird because we don't have like a wire. There's no